Hello everyone. We are group number 7. The industry that we have selected is nuclear industry in Japan. So throughout this presentation, we are going to talk about the role of nuclear technology transfer and collaboration in strengthening the technological capabilities. Here's the content for the presentation. I'll start with the introduction to the technology and to the country. The concept of nuclear power began in 1930s. Enrico Fermi, one of a popular physics firm, first demonstrated that nucleus could break atoms. Fermi led a team at University of Chicago and achieved the first nuclear chain reaction in 1942. Nuclear energy is defined as the energy generated by a change in nucleus of atoms. Normally, changes in nucleus of atoms are caused either by nuclear fusion or by nuclear fission. Nuclear technology is defined as a technology that manipulates certain changes in nucleus and transform them into energy. Nuclear reactions release a very high energy. After a series of milestones, now nuclear energy has become the world's most powerful and reliable energy source. And today, 11% of the world's electricity is provided by about 450 nuclear reactors around the world. Let's surf through some major applications of nuclear technology. Generating electricity is one of the main applications of nuclear technology. Nuclear power plants heat water to produce steam. The steam is used to spin large turbines that generate electricity. Let's talk about nuclear weapons. At the center of every atom is a nucleus. Break that nucleus apart or combining two nucleus together can release large amount of energy. Nuclear weapons use that energy to create an explosion. Nuclear technology is applied to various branches of medicine as well. Oncology, cardiology, and neurology can be taken as example for the areas which nuclear technology has used. In the field of agriculture, nuclear technology is very useful in pest control, increasing food production, and reducing the amount of necessary fertilizers. Nuclear technology also used in areas such as space exploration and isotope hydrology. The development of nuclear technology in Japan began with the Atoms for Peace speech given by US President Dwight D. Eisenhower to the UN General Assembly on 1953. After that, Japan allocated budget for nuclear research. In 1956, Japan joined the International Atomic Energy Agency and formed national nuclear energy bodies. First reactors were constructed by former Japan Atomic Energy Research Institute with the help of Japanese companies like Hitachi, Toshiba, and Mitsubishi. Nuclear power is expected to play an even greater role in the future of Japan. And today there are 39 operable reactors in Japan. And I'll hand over the presentation to Kavin.
So when it comes to the components of technology that has been transferred, according to local conditions, each country has a way to get nuclear power through that technology transfer. From the technical point of view, factors such as national nuclear power development plan, reactor type and size, and capability of research and development, and the level of industrialization and manpower resources must be carefully investigated. And recipient country can use the transfer technology to realize localization. For example, after design technology that has been transferred, the recipient party will have ability to design nuclear power plant through its own efforts. The recipient party can utilize the transferred manufacturing technology to enhance its manufacturing ability and extend local equipment supply. Therefore, they can aiming at the ultimate purpose like realizing localized design, manufacturing, construction, project management, and operation of national nuclear plants carried out through different ways of technology transfer for different nuclear power projects. As I mentioned above, during the implement of National Nuclear Plant Phase 1 project, the objectives of technology transfer were focused on the following: to establish research and development facilities, to train personnel in design, engineering, manufacturing, construction, operation, and maintenance, to accumulate the experience of project management, to establish Q&A systems, to train personnel in large-scale project management match with international practice, including investment control, quality control, and schedule control, to gain experience in constructing large-scale nuclear power through cooperate with foreign vendors, to be able to operate and maintain important nuclear power units independently. For the National Nuclear Plant Phase 2 project, the objectives of technology transfer were focused on following: to enhance the domestic capabilities of project engineering and equipment manufacture through documents, information, and computer codes of the reference plant, as well as consultation of foreign vendors, be able to issue technical specification for procurement of equipment and components in the international market, to increase the domestic capabilities for building large-scale nuclear power units, including engineering, construction, and supply of equipment and components, The manner of technology transfer in Japan can be summarized as follows: purchasing the documents, drawings, and corresponding software, then study and mastering them, asking experienced foreign companies to work with Japan as consultants, dispatching their engineers in various disciplines to get on the job training abroad, and inviting foreign experts to conduct lectures and seminars in Japan. Additionally, in development of nuclear power, they got very useful assistance from the International Atomic Energy Agency, which covers research and development, design and engineering, project management, training of operation and maintenance person. So I will hand over presentation to Sarah to take out the presentation.
Let's talk about the nature of the technology transfer. This is the definition. The technology transfer is known as a process that permits the flow of technology from source to a receiver. So when it comes to the technological transfer, we can clearly categorize according to two main categorizations. First one is done by American economist Edwin Mansfield. This is regarding vertical technology transfer and horizontal technology transfer. When it comes to the geographical categorization, as you can see, it's international technology transfer, regional technology transfer, cross-industry, interfirm, and intrafirm. So if you go to the next slide, we can talk about the story behind the technological transfer. So Japan started nuclear research back in 1954. Their first reactor is produced by 1963 by their own research in their universities and all their commissions and all. They imported their first commercial nuclear power reactor from UK in 1966. So back in 1970s, they cooperate with all these American companies like General Electric and Westinghouse by contractually in order to work with them in order to like grab their knowledge and all their designs and all. So with that, Japanese scientists, they utilize the purchase design from US vendors and they cooperate with Japanese company and they made the similar plants in Japan. That was most of the time their turning point in their industry. So after that, big companies like Hitachi, Toshiba, Mitsubishi in Japan, they're trying to develop capacity to design all these plants. By the end of 1970s, Japanese this industry is largely established. When it comes to today, they exports to the other East Asian countries as well as Europe this nuclear technology. So what my conclusion is, as we have been seeing what's the story, Japan mainly use a hybrid method when it comes to the question whether it is vertical or horizontal. Since first they started with their own research and after that they cope with other countries and they imported the technology and they gained the knowledge and designs and all. And when it comes to 1970, with parallel, they do their own research and applications as well. So with the parallel with cope with other countries, they did their own research and everything of their university as well. I would like to mention they have used a hybrid method. When it comes to geographical categorization, it's clear they have used international technology transfer. But if you take this whole nuclear industry as a whole, it's kind of like a cross-industry transfer because when it comes to technology like nuclear, first they use in defense and weapon industry, but after World War II, they transfer that technology to a good way. So it's like cross-industry transfer as well. So I would like to hand over the presentation to Shanil.
So let's talk about the technology transfer mechanism. Under that, technology transfer of USA. The USA was the leading country in using nuclear energy in early stages. Under the vertical transfer of nuclear energy, the achievement of first controlled nuclear chain reaction and discover of generating electricity from nuclear fission, Manhattan Project in early 1940s, introduction of new fuel type, building of 88 nuclear plants up to 2020. Then government made priority for the nuclear power plants in making fuel sector, security, weapon and other sections. Under the transfer environment, economically, 1970s, USA dominated the international nuclear market and leading supply of uranium enrichment nuclear fuel fabrications was provided by USA. Politically, in 1957, the Act Anderson was enacted and in 1982, Congress passes the Nuclear Waste Policy Act. Orientation, practice strong inward orientation till atomic bomb. Afterwards, they were into more economic wise and was outward orientation.
So our technology transfer is Japan. So Japan lack of energy resources. So they believe nuclear technology to develop their science and engineering workforce. So they used to depend on energy inputs like fossil fuels before the nuclear energy came to their country. In 1957, Japan research reactor was imported to Japan Atomic Energy Research Institute. Also, Japan adapted to use US nuclear technology earlier than other countries. So, talking about transfer environment, Allied forces occupied the nation by bringing drastic changes to government and to the country, and also the government changed as a democratic government. So, Japan also maintained a good, stable relationship between the USA. Also, they access a lot of American technologies. Also, the absolute capacity of new technologies to Japan raised because the Japanese people are very skillful and smart, and they have a good attitude and commitment to change. Talking about the physical organizational infrastructure, with the improvement of these technologies, the economic miracle happened in Japan in 1950s and 1960s. So, talking about the technologies that are being transferred, one is small modular reactor technologies, light water reactor technologies, advanced reactor, and versatile test reactor are the technologies. So, the transfer mechanism is market-oriented mechanism. In market-oriented mechanism, it mainly joint ventures. Talking about the greater environment, signing of the treaty of mutual cooperation and security between Japan and USA is an important point. Also, both countries are part of World Bank and IMF. It is also influent to a good relationship. Also, they together account for 30% of the world domestic product. Finally, the technology and advancement of USA influence Japan.
So let's move to the examples of market-oriented and non-market-oriented mechanisms used in Japanese nuclear power industry. When it comes to the technology transfer methods, there are two main categories: market-oriented mechanisms and non-market-oriented mechanisms. Market-oriented mechanisms refer to the formal market channels; those are more efficient and some form of transaction underlies the technology movement. On the other hand, non-market-oriented mechanisms refer to the technology transfer channels without a formal market transaction. Let's see the examples from Japanese nuclear power industry. So Japan started research and development in nuclear power industry 1954, and it was influenced by the speech delivered by Mr. Eisenhower, the US President, at the UN General Assembly in 1953. We can consider this as a non-market channel. And after that, they started a school called Nuclear Engineering School. It has provided many courses and training programs and conducted many research in order to fulfill the need of infoware and also to develop the humanware. So let's see the market-oriented examples. Japan imported its first commercial nuclear power reactor from the United Kingdom, and it was built by the GEC. And also they purchased the designs of boiling water reactors and pressurized water reactors from the US vendors, and they built them up with the cooperation of Japanese companies, and then later they received the license to construct the similar plants in Japan. So we can see many joint venture companies in Japanese nuclear power industry. In 2000, Japan Nuclear Fuel Company and Toshiba Corporation, Hitachi Limited, and General Electric Company from US formed a joint venture company called Global Nuclear Fuel, and it supply fuel and provide peripheral technology all over the world. And in 2016, Swedish company called Satsvik and Japanese steel manufacturing company called Steel started a joint venture. It was for Welco Satsvik, and the aim was to provide the wastage solutions to the Japanese nuclear power industry. In 2017, Exelon Generation Company from US and Japan Atomic Power Corporation started the joint venture company. It was JEXEL, and the aim was to use the Exelon's expertise in operational excellence and safety with the Japanese reactor technology. So these are some of the methods used by the Japanese nuclear power industry. So Nirasha, it's over to you.
I am going to explain about the conclusion of the report. Due to lack of natural resources in the country, generating energy was a major concern in Japan after the end of World War II. While Japan continued to procure nuclear steam supply systems from US vendors, the country also began developing its own design and manufacturing technology. They transferred equipment as well as they have gotten trained, and they have taken the infoware as well. After some time of US nuclear power reactors, Japan reverse engineered and have successfully acquired technological capability and started developing their own indigenous Japanese plant. According to WNA, the first indigenous plant had performance problems, with capacity factors averaging below 50%. The country embarked on a program to improve nuclear performance and brought the plants up to world standard by the mid-1980s. Now, Japan's nuclear power plants provide about one-third of Japan's electricity. According to WNA, the first indigenous Japanese plants had performance problems, with capacity factors averaging below 50%. The country embarked on a program to improve by the mid-1980s. Now, Japan's nuclear power plants provide about a third of Japan's electricity. Sri Lankan government should establish a long-term plan for nuclear power development. Building and maintaining a nuclear power plant is costly, and the technology selected may and with a lesser population. Sri Lankan energy consumption is relatively lower than Japan, and Sri Lanka is a natural resource nation as opposed to Japan. We can generate power by hydropower plants and coal power plants as well. If you look closely, the hydropower plants can be further developed and used to generate the power needed to the day-to-day activities of the country. As we have higher fauna and flora in the country, we must consider about environment of our country and safety of our people. If we choose a transferring country, we must have a clear understanding between the transferor country and the transferee country. We must choose a good country without hidden intentions about Sri Lanka. It will be best if we send some of our researchers or scientists to a transferor country. It would be a great opportunity if we have a treaty or agreement which they agreed to train our people to the best standards and the world standards. They may be needed to provide some insight in the operating of the power plant and maintaining the power plant as well. In considering the Norachole power plant incident occurred in the Sri Lanka, which caused by the humanware and informaware technology transferring mishaps, we shouldn't have let that happen to nuclear power plants as well, because nuclear power plants are generally more powerful and more harmful as well.
These are the references we had.
These are our team members. Thank you.